This video made for 10th standard. The chapter name is Linear Equations in Two Variables. Definition: the equation ax plus by plus c equal to 0 is known as linear equation in two variables x and y. So therefore this is a linear equation in two variables. So what are the two variables? X and y. Why it is called a linear equation? The powers of the variables x and y are 1. That's why it is called a linear equation in two variables. Suppose the powers of x and y are 2, 3, 4 like that. They are called a quadratic, cubic and fourth degree based on what? The numbers. So here we'll see only linear equations. Linear equations in two variables means their powers must be what? 1. X and y powers must be 1. That is the important thing you have to understand from the word linear equations in two variables. So observations over this equation. So if you have what these observations, you can able to understand further in the chapters. Definitions and calculations you can able to understand. So that's why you will take what proper observations over this equation ax plus by plus c equal to 0. First, a. So x and y are what? Variables of this equation. Then what about other variables used in this equation a, b, c we want to define. So that's why we needed this observation. First a, next b, and then c. These three we want to discuss. A is called a coefficient of x. Coefficient of x. B, coefficient of y. C, constant term in the equation. So if I ask what a coefficient of x, you have to identify a. B means coefficient of y means b and constant term means c. So that observation is very important. Next, objective. Objective of this chapter. Aim of this chapter. What we are going to discuss on the whole. The purpose of this chapter is to study nature of solution of the system of two linear equations. Two linear equations. And to find a solution, or we have to find the solution of this system of equation. That is what aim of this chapter. In next, let us consider the two linear equations. The whole chapter or formulas all we are going to derive through the following equations. The first equation always taken as a1x plus b1y plus c1 equal to 0. And second equation a2x plus b2y plus c2 equal to 0. So two linear equations are taken here, are going to be considered in the whole discussion. Equation 1 a1x plus b1y plus c1 equal to 0. a2x plus b2y plus c2 equal to 0. Together the equation is called together of these two equations is called system of equations. That is the next observation. Next we'll go what concept? Nature of solution or solutions. So the nature of solutions of the system means what? Together of the equations. The nature of solutions of the system of two equations completely depends on three ratios. Three ratios. What are the three ratios? The first ratio a1 by a2. a1 is what? Coefficient of x in the first equation. a2 is coefficient of second x in the second equation. That ratio. And b1 by b2, and third ratio c1 by c2. So the nature of solution depends on these three ratios. So you have to get ready to calculate these three values to find out the nature of the roots of the or solutions of the equation. Okay, that is the second observation. So I'm going to define one word here called inconsistent system. Inconsistent. Mathematically or algebraically we'll talk inconsistent system. So if the relation between the ratios a1 by a2 is equal to b1 by b2 is not equal to c1 by c2 now, then the system of two equations are called inconsistent system. The system is called inconsistent system. Inconsistent system. Next, consistent system. So if the system is not consistent, then the system is called consistent. If the system is not inconsistent, then the system is called consistent. So only one condition we can take to say whether consistent or inconsistent. So what is that condition now? Algebraic condition a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. That condition we have to check. If it is true, you have to say inconsistent. If it is not, you can say the system is consistent. Okay. Next, existence of solution of system. So first we checked consistent and inconsistent. Now existence of solution of system of equations. Existence means whether the system has solution or not. So that is called what? Existence of solution of system of equation. Okay, we'll go one by one. So here I collected as a tabular form. The total study is in tabular form. Okay, let's see first. Test. So I have what three cases. First case a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. One case. Case 2 a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Case 3 a1 by a2 not equal to b1 by b2. Anyway, so the test is made on what? The comparison between these three ratios. Okay. Solution and number of solutions. Okay. First, if it holds the first condition a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, you can say the system has no solution. So first case says that no solution. No solution means number of solution is what? 0. Suppose the system holds second condition. What is the second condition? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Then the system will have infinitely many solutions. Infinitely many solutions. So that is symbolized as what? Infinity. Next, suppose the system holds the third condition. a1 by a2 is not equal to b1 by b2. You can say what? Unique solution. Unique solution means exactly one solution. So we have to take it what? The three ratios and compare in this way, fix the case, conclude the solution. No solution, infinitely many solutions, or unique solutions according to that. Okay, I want to make one point here. So always you compare what? The first two pairs a1 by a2 and b1 by b2. If they are not equal, immediately you have to conclude unique solutions. Okay, then only you have to move the next case. If it is equal, I said not equal, immediately you can conclude unique solutions. If they are equal, you have to go over the first case. You just compare second and third pair. Second and third pair. If they are not equal, you can say no solutions. Okay. If all three are what? Equal, that is the last case. So my suggestion is that you have to compare first two pairs. If they are not equal, unique solution. Okay. Next, geometrical meaning. Geometrically, we used to call what? A geometrical interpretation of system of equations. Okay, we'll call simply here geometrically. What is meant by this two? So parallel lines. So no solution case will give what? Parallel lines. A1 by A2 is equal to B1 by B2 is not equal to C1 by 2 C2 na. No solution. In that case we can say they are parallel lines. So ratios are equal, we can say coincident lines, or infinitely many solution cases will give what? Coincident lines, or coincident lines will give what? Infinitely many solution. Last one, intersecting lines. Unique solution is obtained by intersecting lines. That is what geometrical meaning. Suppose if it is taken into graph, these equations are taken into graph. So we'll get what? Parallel lines like this. Coincident lines. Coincident lines means basically we know that one line lying on what? The other line. So that is an example here given. So one red color line, other one yellow color line lies on it. This is for what? Intersecting. So they are intersecting at only one point. That point actually called what? Solution for the system. Okay. So in this tabular column we will add one more point about what a consistent. You can see that inconsistent parallel lines, no solution, or A1 by A2 is equal to B1 by B2 is not equal to C1 by C2 na. It's called what? Inconsistent. So you can connect about one thing. No solution is called what? Inconsistent. Inconsistent, no solution. Consistent. These two cases are taken as what? Consistent. So consistent indirectly means that there will be what? Some solution. If there is a solution, you can call the system is what? Consistent. If there is no solution, you can call what? Inconsistent. Okay. So consistent has what? Two cases. Infinitely many solutions and unique solutions. Inconsistent has what? Only one conclusion or case, that is what? No solution or zero number of solutions. Okay. So this study will do or will shake through what? On example. Test the consistency of the following equations and write about the existence of solutions. Existence of solution means I'm saying what number of solutions. Okay, here I will consider three set of equations. 1, 2x plus 3y plus 4 equal to 0. 3x plus 3y plus 2 equal to 0. These two equations is taken in as what? One system. So this system may have what solution or not having what? Any solutions, that we will discuss. Another system, 2x plus 3y plus 6 equal to 0. 4x plus 6y plus 12 equal to 0. 2x plus 3y plus 4 equal to 0. 4x plus 6y plus 7 equal to 0. I took what? Three systems because we have three cases, no? So these three system going to be taken for what? Three cases. We'll find the solution. First case, first system, 2x plus 3y plus 4 equal to 0, 3x plus 3y plus 2 equal to 0 is taken for what? To test the consistency and about existence of solutions. I told you, if you want to find or if you want to test the consistency and want to know about what the existence of solutions, you have to find out what the three ratios. What are the three ratios? A1 by A2, B1 by B2, C1 by C2. What is A1? Coefficient of X, B1 coefficient of Y, C1 constant term. A2 coefficient of X, B2 coefficient of Y, C2 constant term. So we'll find these three pairs first, three ratios. See, A1 by A2 is equal to what? 2 by 3 because coefficient of X is 2 in first equation, coefficient of X is 3 in the second equation, likewise. Okay. So B1 by B2 is equal to 3 by 3 is equal to 1. Not necessary to find what a third pair now, but even though that is the procedure, we'll find. C1 by C2 is equal to 4 by 2 is equal to 2. Okay, we calculated what all the three pairs. The first ratio 2/3, second ratio 1, third ratio is what 2. So what is our observation here? We observed that A1 by A2 is not equal to B1 by B2. I told you first two pairs are not equal. We can say the system is consistent and it has unique solution. So geometrically it means intersecting lines. So that point of intersection is what solution of this system. Okay, we are not going to find solution now. This is the basic class. So first we'll test the consistency and we'll report about what number of solutions of the equation. The next video we'll see what solution of system of equation. Okay, it's over. Second set of equations or system of equations. I'll take like 2x plus 3y plus 6 equal to 0, 4x plus 6y plus 12 equal to 0. Again, we are going to find what the three ratios a1 by a2, b1 by b2 and c1 by c2. Are you clear with that? See coefficient, what is the ratio of first one? 2 by 4. X coefficient 2, y coefficient 4, 2 by 4. The simplest form of 2 by 4 is what? 1 by 2. Second ratio, b1 by b2 is equal to 3 by 6. The simplest form is what? 1 by 2. Third ratio, 6 by 12. 6 by 12 is nothing but 1 by 2. So we have to bring that ratio into what its most reduced form. Then only we can able to compare very quickly. Okay, so 1 by 2, 1 by 2, 1 by 2. So what is our observation? We observed that a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Therefore, what is our conclusion? The system of equation is consistent. The system of equation both are taken as what one group. So single group is what system of equation is what consistent, and it has infinitely many solutions. Consistent, but it will have what infinitely many solutions. Okay, so geometrical meaning. So infinitely many solutions now. One line lying on what another line, that is called what coincident lines. So we'll go what third case, last case. 2x plus 3y plus 4 equal to 0. 4x plus 6y plus 7 equal to 0. I'm going to consider this is what the system of equation for the next example. As usual, we are going to find the three ratios a1 by a2, b1 by b2, c1 by c2. First we'll calculate a1 by a2. 2 by 4, 2 by 4 is what? 1 by 2. Next b1 by b2. 3 by 6 is equal to 1 by 2. And last one c1 by c2, 4 by 7. Okay, again our observation. So we observed that a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. So as per the table column, the system of equation is inconsistent and has no solution, and graphically they are what? Parallel lines. That's all. So no solutions will give what? No point of intersection. So that's why they are what? Parallel lines. So solutions are nothing but what? Point of intersection of two lines. That's all. So thank you.